Alright guys, here's the latest job to come through the door. This is another cast iron door for a wood burning or coal burning stove. I'm not quite sure, but you can see that we have a broken hinge pin. One of the grates is completely broken in half, and I just hit this with the sandblaster real quick in here. I don't know how well you can see it, but there is another crack forming right in there that I couldn't see in the original photos that I saw of this thing. So before I do any type of welding whatsoever, I'm going to sandblast this and look for other cracks and defects that I need to identify before I start the process. So let me get that done, and we'll see where we are. Alright guys, you see that Dana has been able to sandblast the large portion of the grate. Got a better look at that hairline crack. And one of the things I was kind of worried about, and it turned out to be a justifiable concern, you may notice there's some green highlights in this, and I don't know how well you can see it, but all this has to be sandblasted out, and it's definitely going to take a while. That looks like a porcelain coating that was originally applied to the stove, so that's not completely uncommon. I've seen that before. Looks like this stove's been around for a while. This was a popular color years and years ago. It's kind of like a very light sea green, and I'm not sure. I'm going to do a little bit of research. But there's a maker's mark on this door. I don't recognize it off the top of my head. I did a little search on the internet. I found something called Warm Morning, but I don't think that's their logo, unless they really changed it a lot. But yeah, not recognizing the mark. But you know, if somebody out there knows who that is, please write it in the comments. I'd be pretty curious to find out who it is, learn more about them. Well, we got to put this back on the sandblaster. We're just giving our air compressor a break. We don't want it to overheat. It is kind of warm out today, even though it's September. And we will sandblast this, and I'll figure out what to do with that hinge as soon as it comes out. Alright guys, it's out of sandblast. Dana took her time and got all of the old porcelain off. We searched the frame, and that was the only crack that we found in the bigger piece. We still have the brake on top and bottom, and we have the hinge, the little nub that completely cracked off. This is going to be the tricky one, because that has to align just right, and usually you use the crack to determine what the position was. But if I bevel this like I'm supposed to and run a bead in there, the bevel is going to take away where the crack line is, and I'm not going to be able to see the alignment. So what I'm going to end up doing, I'm going to come in and I'm going to bevel the inside of it right along the back of this tab, and I'm going to run a bead in there. Then I'm going to come back with a Dremel tool and bevel all of the rest of it, and I'm going to complete the weld from there. So I'm going to have the weld all the way around. I'm going to have the bevel all the way around, but I'm still going to use the crack to index how this lines up. The next weld I'm going to do is going to be this one. I'm going to just come in here with an angle grinder. I'm going to cut completely about halfway through one side, run a bead, flip it over, do the same thing to the other side, and make sure that that's nice and solid and completely cut the crack out of the cast. Then the final repair, which is going to be the easiest to line up, are going to be the full brakes, the top and bottom where it broke apart over here. This one's pretty straight. This one's kind of jagged, but again, I'm going to come in, I'm going to bevel one side of this, I'm going to bevel the opposite side on here. So it's going to fit together front to back, and it's going to line up. I'll run a bead here, and I'll run a bead on the back of this, flip the piece over, bevel the opposite sides, and do the TIG weld. So, let's get started. I have this offset just a bit so you can see the crack. It almost lines up perfect where the camera won't even pick it up. But it's just about a hair off, and it's just so the camera can catch the crack so you guys can see what we're doing here. On the inside, you can see how I beveled, and that is where I'm going to put my first pass with the TIG. Now, before I do that, I'm going to preheat this entire piece, or at least a good portion of it, and then I'm going to take it and I'm going to go stick it over on the wood-burning stove. The wood-burning stove is running probably about 500, maybe 550 degrees in the top, and it'll keep it from cooling too quickly. It'll maintain its heat for quite a while, and it'll allow me to start on the bigger piece, fixing that hairline crack. So I've got the hinge beveled. I'm ready to do the weld on the back. I want to make sure that everything's still nice and straight, looks good. I've got the torch on it, keeping it warm while I'm doing other things in the background. And right now I'm going to get set up. I just got it weighted down with an angle plate, and I've got a little vise behind that so it won't slip back on me in case I bump it. But I'm going to take the torch away, and I'm going to run my second TIG pass. Okay guys, there's the weld. Now cast iron does leave a few impurities in here and there, so I might have to grind out a little bit, but this looks to be okay. Looks like I also need to change the battery on my camcorder, so don't go away. I'll be right back. I gotta go throw this on the stove, and I'll start prepping my next piece. Alright YouTube, I got the big section of the door and that hairline crack ready to weld. You can see that I beveled out the crack, and I'm going to run my first TIG pass, throw it over on the wood-burning stove to keep it warm, let it cool down a little bit to maybe 400 or 500 degrees. Then I'm going to go in and bevel the other side and weld there as well. So let me remove the torch and get welding. Alright guys, I did a little bit of grinding, and I sandblasted the welded area again to do a little bit of stress relief. I cooled it down over a period of a few hours, but if you remember, that's where the crack was, and the crack is completely gone. There is nickel in there now, and what I need to do is flip this over. On the back side I didn't sandblast it, but you can still see the discoloration from the welding and from the heating. That's the heat pattern there. And I don't know if you can barely see it, but let me see if I can find it here. Right there, that is the back side of the crack. So I'm going to start with the grinding wheel from there and come down to here. This is actually some of my puddle right here. This is nickel, and I'm going to cut a swatch straight through this nickel, this cast iron, to that notch right there. And what my goal is to get down to nickel. So when I see the nickel through the weld, I'll know that I'm all the way through, and I'll just run a bead from here to here. I'm going to preheat it, of course, TIG weld it, and then throw it back up on the stove. But you can see shooting for a, I wouldn't really call this restoration quality. This isn't going to be like a museum quality piece when I'm done. I honestly don't have the tools for that, but obviously I'm going to do the best job I can. Alright YouTube, I find myself at a point in the project where I could sit and talk to you for a couple of minutes, answer a couple of questions that were brought up in the last TIG welding cast iron video that I did, and maybe give you a little bit of background on this project. I'm going to start off with, this is not a repeat necessarily of a TIG welding cast iron video that I have already done. While the process is similar, I'm using the same kind of rod. You may recall the last stove door was a completely flat surface and it had one of the hinges broken off. I was able to create an open root weld that I did with the nickel rod, and then I put the hinge back on using a brass dowel to hold the hinge parallel with the hinge that was already on the door. This is a little bit more complicated. It's got concave and convex surfaces. There's a nice design in it. I'm not sure what the manufacturer is of this stove, but it looks like a really nice piece. Excuse me. And it's just a lot more in-depth. It's got cracks, it's got complete breaks, plus I have to weld small parts. So it's challenging, but I'm enjoying the project so far, and I actually like challenging projects. But I figured since I am waiting for parts to cool, I'd answer a couple of questions that came up in the last TIG welding video that I did. The first question that I got the most of is, what kind of rod am I using? I am using a Tech Alloy 55, and according to the manufacturer, I'm going to read this right to you, the content of materials breaks down as follows. I've got 55.9% nickel, 43.6% iron, 0.25% manganese, 0.05% carbon, and 0.15% silicon. Now, another question that somebody asked is, how much does a repair like this cost? And that's a fair question, because a lot of people out there are probably wondering. It does take a certain level of skill to do this sort of thing, and it takes a lot of patience, and it does take a lot of time to do it right. In a professional welding shop, something like this would cost probably around $180 to $200, especially having to sandblast it and get all the porcelain off before we could do the welding and make sure the part was completely clean. The client did send me photos of the damper before it got here. I did not realize that there was porcelain underneath, but it got here, I took a look at it, and I quoted him a price of $40. And I did that for two reasons. One, I really enjoy a challenge, and I like being able to make videos about little neat projects like this, and this is going to benefit a lot of people, especially if they take the time to watch the video. And hopefully somebody will pick something up, they'll learn something, they'll go out, try it on their own, and hey, you know, just trying to spread the knowledge. So to me, 40 bucks, it's well worth it. Now, the material, these rods, this is an 1/8 inch diameter rod. I do wish that I had a smaller rod for this project, getting into some of the tighter areas, but I got to use what I have. This nickel rod runs, at least at my supplier, it was $60 a pound. And a pound, I believe, was 7 rods. So yes, it's very expensive. But the upside is you don't use a lot of it. This was originally a 36-inch rod. I used it for the entire first TIG welding cast iron video. I'm probably going to be using maybe about, I'm probably going to be using about that much more of it for this project. And I've done 2 other cast iron welding projects with this rod. This is the first rod. So it does last a while, and even though it's expensive, it is pretty economical, especially if you're going to be able to do it yourself. Some of the other questions that I had. What do I have my gas pressure set at? What's my regulator set at? When I'm doing TIG welding, I usually run between 25 and 30 CFH, it's cubic feet per hour. Another question was, am I running straight argon or am I running an argon CO2 mix? For this, I'm running straight argon. I typically weld everything TIG with straight argon. I find it just to work fine for me. And, you know, hey, I have no reason to fix it. It's not broken. Another question, what do I have my machine set at for amperage? Right now I'm running 120 amps for this particular project. The first door that I did, because it was a thinner metal, I ran it at, I believe, 100 amps. And that's another difference between the last door and this one. The last door was completely flat and it was pretty uniform in thickness all the way around. Because this one has the cast design in it, I'm finding that there are areas that are 1/4 inch thick that go down to 1/8 of an inch, then they get thicker again. It's a lot more difficult to weld, and yes, I'm going to be leaving a weld bead, and even though I don't like grinding welds, I'm going to have to just to make sure this project comes out the way it's supposed to. Leaving a nice weld bead on it may be attractive to some people, but this is going into someone's home, and I want it to look as close to original as I can get it. A little bit of background about this particular project. In one video I said that you're not going to get a lot of work off of YouTube, and I may have spoke too soon. The gentleman who owns this, excuse me, who owns this stove damper lives out in Arizona, and he looked around the web, he saw my video, liked what he saw, sent me an email, I need water, sent me an email, asked me if I would be interested in the project, and he shipped me this damper from Arizona. So here I am, his little shop in, Connecticut, and I'm getting work now shipped to me from across the country, which is, it's something I never expected. It's kind of a happy side effect of YouTube. So this is why I want to share as much as I can with the YouTube community. I know personally I learn a lot off of YouTube. I've gotten a lot of good helpful hints and tricks, and I do appreciate everybody out there who posts videos, especially ones that have an educational value to them. I also enjoy the ones that have the titles such as 50 caliber versus lawnmower. Those are always kind of fun. But anyway, I hope that answers a couple of your questions. I'm going to get back to this project, so I'll see you in a couple of minutes back underneath my leathers. Alright YouTube, as you can see, this is starting to take shape again. Just took these both off the stove. I'm getting ready to put a bead, well actually a tack there, then I'll finish the bead. I got to move the clamp. The back of that is beveled. The front is not, and then up here I beveled the front and not the back, and I'll weld that, flip the piece over, and then weld that on the back, and then I'll bevel with the angle grinder the opposite sides and do my weld. I just figured that this is the best way to do it, keep things straight, keep the heat even, and it still allows me to use the cracks to line the piece up to make sure everything's sitting properly and gets welded where it needs to be. Alright YouTube, well, just like the last video, I have everything welded together. Ran through the cool down cycle with the torch, got it down to about 500 degrees. And now I'm going to allow it to sit on top of the wood burning stove. Got a fire going on the inside. And as that burns out and cools, this will gradually cool as well. And once that's done, probably about 3-4 hours, I will be able to have it at a temperature where I can start the final grinding, profile all of these little inlays over here, all these little decorative parts with my pencil grinder, and we'll be good to go. Give it another sandblast, blend it all in, and she'll be ready for paint. Alright YouTube, here's the finished door before grinding. It's cool to the touch. I just took it off the stove. We're about 4 hours after the welding's done. And you can see that there's a lot of cleanup that needs to be done on these welds. With cast iron, I find that there's a lot of impurities that come to the surface. You could be sitting there welding and you get a good decent puddle on there, and you just get this, it almost looks like a bubble that pops inside the weld puddle. And I don't know if that's something to do with the cast iron itself. I really couldn't tell you. But you may see me go back and forth and hit it 1 or 2 times with the TIG torch. Even without filler rod, that just try to blend all that back in together. If I find a low spot, then I'll go back in and add more rod to it. But now this is kind of where the artistry begins. I have a couple of tools over here. That is the pencil grinder. Got a nice stone tip on that that's going to let me do a lot of the contour work. I have a pneumatic small belt sander with a very narrow belt on it that'll let me get into tight places. And last but not least, I've got my angle grinder set up, and I've got a couple of extra pads and discs ready to go. Alright YouTube, it took me about 35, maybe 40 minutes to profile everything the way I wanted it to with the pencil grinder, the belt sander, and my angle grinder. But it was well worth it. I wish I did have some more time to put into it, but the gentleman who mailed me this door from Arizona is leaving. I think he's actually leaving the state of Arizona to go to a cabin that he has, and he really wants to take this, this stove door with him because the stove is in his cabin. So let me show you what we did. Got one repair, got the side back on, and welded on the little hinge piece. Now, if I get real close, you could tell, you know, compared to the factory version, this one is right out of the mold, this one is the repair. But, you know, you get a couple feet away from it, it's really not noticeable unless you're looking for it. Like I said, I wish I had a little more time to put into it. The corner came out really nice. I actually had to go in with a manual file and cut this corner in because it's kind of rounded out from my weld puddle. But that's the repair, and that's the factory. So, you know, like I said, you can't expect to be perfect because, you know, only the mold is perfect. And, you know, we do the best we can. And, yeah, it's, you might notice that it's black. I ran to Home Depot and grabbed a can of Rust-Oleum high heat. It's good for 2,000 degrees, and you know, you're not going to find anything really hotter than that. Plus, this is just a damper. It's not really a stove door. If I had to guess, I would say that this is actually below the firebox, and heat rises, so this is not going to get near 2,000 degrees. So I'm going to put probably another coat, maybe 2 coats of paint on it. It's got 2 coats on it right now, but I want to send it out with a really nice protective coating. And then I'll attach the rest of the damper assembly and put it back together. And tomorrow it will ship out to Arizona. Alright YouTube, I'm going to wrap up another video here. Dana already went home. It's actually kind of late. It's almost midnight. I'm going to go home and, well, go home, but go in the house and maybe do a little editing, try to get this up tomorrow. There are some people out there that think I'm crazy for doing a job like this for 40 bucks. And I'll tell you, maybe I am a little crazy, but I really do enjoy passing along what I know. I really do enjoy a challenge, and my last TIG Welding cast iron video got me a ton of new subscribers. So, you know, it's worth it. And for me to go out and hunt down a project like this, you know, I just wait to see what comes through the door. The only reason I charged 40 bucks, really, I mean, to be honest with you, I have to cover the cost of materials, and, you know, gotta charge something, I guess. But, you know, it covers the cost of gas and consumables and rod and things like that. But these are the projects I really enjoy, especially when it's something old like this. I really like trying to preserve history. I like doing repair work because in today's day and age, it seems like we live in a disposable society where everybody's just so eager to throw things away and buy new. And that's not the way it was years ago. And I was very fortunate. I mean, I got to meet my great-grandfather. I knew him until I was, you know, he was alive until I was a teenager. I had my other grandfather who was always hands-on, fixing stuff and tinkering around in the garage. And then, of course, my father. And, you know, they were the kind of guys that, you know, let's see if we could fix this. Let's you know, just put a little thought and some effort into it and, you know, take care of something, and you know, you have it for a long time. But I'm going to cut the video here before I just keep on rambling off into the sunset. Well, the sun's already set, but you know what I mean. Alright guys, this has been another video from Darkmoon Metals. I'm Jeff, and I'll see you again soon.